Welcome to the Deep Dive. We're the place that cuts through the noise to get you the impactful data. Today, we are really digging into the financial sector
Hmm.
because generative AI, Gen AI, it isn't just another tool. It feels more like, well, the new operating system for finance's future. We're looking at real numbers, the kind of complex architectures involved, and yeah, the big risks too.
Absolutely. Financial services are right at the forefront, really pushing the boundaries of this tech revolution. Our goal today, is to get past the hype. We want to distill what's actually happening. We'll cover the specific AI models making this possible, the, frankly, staggering efficiency gains, and the ethical guardrails everyone's scrambling to build.
And let's start with some proof. This isn't sci-fi anymore. It's serious capital investment. The
Yeah.
smart money is definitely moving. The global market forecast for Gen AI in finance,
Mhm.
it's expected to hit something like $16.2 billion between now and 2030.
16.2 billion.
Yeah.
Wow.
A lot of that growth, driven by AI chatbots, those customer-facing systems.
And it's not just projections. We're seeing real data from the early adopters already. Some institutions are reporting immediate cost cuts, up to 35% in certain operational processes. But here's the kicker for me. Customer response times, down by an average of 60%.
60% faster.
Yeah. And first contact resolution, solving the problem the first time someone calls, that's up to 85%. Customers get answers quicker, and they don't need to call back. It's a huge win-win.
That really is the bottom line, isn't it? Gen AI is touching everything. Getting a loan, managing massive trades, everything. We've seen reports mentioning operational efficiency boosts, sometimes up to 40% just in routine back office stuff.
And crucially, it's not just about doing things faster. It's about accuracy. That's paramount in finance, obviously. We're seeing error rates in risk assessment drop by up to 60% compared to the old ways, the often manual methods. It's shifting risk management from putting out fires to actually preventing them, much more proactive.
Okay, I see the efficiency gains.
Yeah.
But what about the sophistication? I mean, automation isn't new. Why is Gen AI such a leap compared to, say, older machine learning?
That really is the core difference, yeah. Traditional ML was good at automating based on existing patterns, finding needles in haystacks. Gen AI creates. It generates new, sophisticated, context-aware solutions. Think about its ability to understand language, natural language processing, NLP.
Right.
The sources show accuracy rates hitting over 92% when processing complex, unstructured financial documents. These things are dense.
So it's not just scanning keywords.
Exactly. It's grasping nuance context. That 92% comprehension is a major reason why risk assessment is improving so dramatically.
Okay, that level of intelligence is, well, that's pretty wild. But if we want to understand how they hit 92%, we need to look past just AI. We need to look under the hood, right? Our sources point to three main engines: GenANs, VAEs, and transformers.
Right. Generative adversarial networks, variational autoencoders, and transformer models. These are basically the non-negotiables for a serious Gen AI strategy now. Let's start with GANs. They're kind of finance's answer to the privacy paradox.
The privacy paradox.
Yeah.
You mean needing customer data to train models, but absolutely not being able to expose that sensitive data.
Precisely. So imagine a GAN as two AI networks locked in a duel. One's a counterfeiter, the generator. It creates totally synthetic financial data. Fake, but realistic. The other's a detective, the discriminator. Its only job is to tell the real data from the fake data made by the generator.
Ah, so they constantly challenge each other.
Exactly. Through this adversarial training, the generator gets incredibly good at mimicking the statistical patterns of real data, what makes it look and feel real, but without ever seeing the original private data.
So it learns the rules, the patterns, but not the personal details, making it almost impossible to reverse engineer back to an individual customer. That's huge for compliance.
It is, and the results back it up. Institutions using GN-generated synthetic data, they've reported a 35% drop in false positives in fraud detection,
While keeping accuracy high.
while keeping detection accuracy above 90%. And demand for the synthetic data is booming. The market's projected to hit maybe $2.1 billion by 2025.
Okay, hold on a second, though. If these generators are getting that good at making fake, but statistically perfect financial data, doesn't that also make things easier for sophisticated attackers, creating fake identities, fake transactions? Is this a double-edged sword?
That's a really sharp point, and it's exactly why regulators are so focused on things like data lineage and explainability and making sure the good guys control the creation, not malicious actors. It's a constant battle.
Okay, moving on then. Next up, variational autoencoders, VAEs. If genes tackle privacy, what's the problem VAEs solve?
VAEs are all about handling uncertainty. Think about traditional financial models. They often spit out a single prediction, right? A fixed number for tomorrow's stock price, maybe. VAEs work differently. They embrace probability.
Probabilistic. Okay, that sounds a bit abstract. Could you, give an analogy?
Sure, think of a VAE less like a precise predictor and more like a weather forecast for the market. Instead of just saying sunny, it gives you probabilities. 70% chance of sun, 20% chance of clouds, 10% chance of rain. It models data as distributions, capturing the inherent uncertainty and all the possible variations in financial markets.
That sounds incredibly useful for risk management. Stress testing against multiple futures, not just one expected path.
Exactly.
But if VAEs model uncertainty, are we just swapping one black box for another? How do institutions learn to trust a model that's built around probabilities, not certainties?
Well, it forces a different kind of analysis. They use VAEs in portfolio management and risk modeling specifically to generate multiple plausible market scenarios. They sample from those probability distributions. It pushes them to stress test strategies against scenarios they might have otherwise ignored, those low probability, high impact black swan type events.
And does it work?
The data suggests yes. Systems using VAEs have improved the coverage of potential market scenarios by around 55%. And they do it faster, about a 45% reduction in the processing time needed for those complex stress tests.
Okay, so JANs for privacy, VAEs for uncertainty. Yeah. That brings us to the last one, the one everyone's heard of, transformer models. The engine behind things like ChatGPT. We know they're great at, writing emails or summarizing text, but what makes them so revolutionary for finance?
It's their ability to read and truly understand massive amounts of unstructured text. Think regulatory documents, earnings reports, news feeds. The key is something called the self-attention mechanism. Imagine reading a huge, dense report. A transformer doesn't just read linearly.
Right, it connects things.
Exactly. It dynamically weighs the importance of every single word or phrase against every other part of the document all at once. It sees the whole picture.
So it spots connections, like a risk mentioned early on and how it relates to a financial figure way later in the report. Global context and local detail simultaneously.
Precisely. It understands those deep, complex relationships. For compliance teams drowning in paperwork, this kind of parallel processing is a lifesaver.
And the return on investment reflects that, I assume.
Oh, definitely. Transformer models are driving about a 50% reduction in general document processing time. And for specific regulatory docs, up to 60% faster processing.
While keeping accuracy high.
While maintaining accuracy above 90% for critical compliance monitoring tasks, speed and precision.
Okay, this is where it gets really interesting for me. We know the tools, JANs, VAEs, transformers. Where are they actually being deployed on the ground to, make money and cut risk? Let's start with the customer side.
Right. Customer service is probably the most visible area. We're seeing about a 55% cut in the time it takes to resolve customer queries. And these AI agents, they're handling complex financial questions with around 87% accuracy.
That's impressive.
And for big global banks, this helps massively with cross-border services. AI translation and localization can cut those specific costs by 40%, making international service delivery about 52% more efficient.
Okay, now let's shift to the back office. The really high-stakes stuff. Risk management and compliance.
Yeah, this is where GenAI offers some of the deepest leverage. The numbers are pretty stark. We're seeing about a 63% improvement in early risk detection rates, catching problems sooner. And remember the false positives issue with JANs. Overall, there's a 58% reduction in false alarms during fraud monitoring.
While still catching the real fraud.
While still catching the real fraud detection accuracy is holding strong, above 91%.
And the real slog for banks' regulatory compliance. All those acronyms. AML, KYC.
Absolutely. AI is automating huge chunks of that. For anti-money laundering, AML AI systems are showing 85% greater accuracy compared to older rule-based methods. Know your customer KYC checks, that used to take days sometimes, now down to hours with 95% accuracy. And think about filing those massive reports, Basel III, SEC filings. AI systems are hitting 90% accuracy there too.
So for the compliance officers, less grunt work, fewer errors, and presumably big cost savings.
That's the net result. Overall, institutions are reporting about a 57% improvement in the accuracy of their regulatory reporting and around a 45% reduction in the operational costs tied just to compliance.
Okay, and the final big area, trading and investment strategies. How's GenAI changing the game on the trading floor?
It's essentially giving human traders superpowers in pattern recognition. AI systems are showing a 72% improvement in spotting known technical patterns in charts. Think Head and shoulders, double tops, things like that, with about 85% accuracy.
But it's more than just chart patterns, right?
Oh, yeah. Crucially, they can detect really subtle, complex behavioral patterns, things hidden in the order flow data, like shifts in market momentum or the footprints of large institutional trades, even shifts in market sentiment derived from news.
And when you have that better analysis,
hmm
presumably you get better returns.
The data suggests so. Portfolios optimized using AI have shown, on average, about a 38% improvement in risk-adjusted returns compared to traditional management styles.
38% improvement. Okay, that single number explains a lot about why so much capital is pouring into this
It
space.
really does.
But this raises, the critical flip side.
Yeah.
With this much power, this much sophistication, what are the big risks? The sources are clear. Data privacy is a massive challenge, affecting nearly, 78% of AI projects? And bias. Without careful oversight, bias incidents are popping up in maybe 40% of cases, especially in really sensitive areas like deciding who gets credit.
That's the essential counterbalance, isn't it? The innovation has to be matched step for step with ethical rigor, especially when you're talking about people's financial lives, lending, insurance pricing. We have to prevent those 40% bias incidents. They can't happen.
So if an AI flags a transaction or denies a loan, the bank needs to understand why, not just accept the output.
Which brings us to explainable AI, XAI. This seems vital. XAI is basically the show your work button for AI. Instead of an inscrutable black box, you get tools that provide transparency, an audit trail. For instance, banks are using techniques like LIME, that stands for Local Interpretable Model Agnostic Explanations for Credit Decisions.
Okay.
So if a loan gets rejected, LIME can tell the compliance team, okay, the model flagged these specific factors, maybe debt-to-income ratio, credit history length, rather than just a computer says no.
And I saw mention of another tool, SHAP values, used in portfolio management. What do they do?
Right. SHAP values try to quantify exactly how much each individual market factor, interest rates, inflation data, new sentiment, whatever, contributed to a specific investment decision made by the AI.
For accountability.
Exactly. If the AI makes a big trade, SHAP values help prove to regulators why it made that trade based on the data it saw.
And I thought this was fascinating counterfactual explanations, where the AI actually tells a customer, here's what you would need to change to get approved for that loan.
Yeah, it's a really powerful use of transparency. It changes the dynamic from just rejected to here's a potential path forward.
And it's not just about ethics, right?
Yeah.
This XAI stuff actually helps with audits.
It does. Implementing these kinds of XAI frameworks leads to about a 55% increase in successful regulatory audits. It demonstrates control. But beyond ethics and explainability, there's just the raw operational risk. The sources say something like 62% of institutions hit significant operational hurdles when they first try to implement this stuff.
You mean things breaking? Like if the AI system processing millions of payments suddenly goes offline, the bank could effectively go down too.
Precisely.
So what are the required safety nets? The fallback mechanisms to
Yeah.
keep things running?
Well, the standard everyone aims for is service availability above 99.9%. 5 nines, ideally. To get there, you need multiple layers of redundancy. That means having backup AI models ready to take over, maybe simpler rule-based systems for basic transactions if the main Gen AI fails, and critically, automated failover to traditional, maybe human-supervised processes for the absolute most critical functions. You can't afford downtime.
That focus on robustness leads us perfectly into strategy. How do institutions actually manage this huge shift? How do they implement Gen AI without, blowing up their existing systems?
It has to be methodical, very deliberate. First, any potential solution has to meet clear criteria. Model accuracy needs to be consistently above 85% minimum. But the real kicker is often scalability. Can the system handle massive growth? We're talking maybe a 30% jump in transaction volume year over year, 40% more users hitting it at the same time.
All while staying fast.
All while keeping response times super low, like under 100 milliseconds. Speed and capacity are just table stakes now.
And we can't ignore the long-term costs. This isn't like buying software off the shelf once.
That's the hidden commitment, isn't it? You have to budget for ongoing maintenance, constant monitoring, regular upgrades. That stuff accounts for 45% to 50% of the total cost over 5 years.
Half the cost is just keeping it running safely.
Pretty much. You're signing up for a long-term, intensive relationship with this technology.
Which is why just flipping a switch to turn everything on at once sounds like, corporate suicide. The sources really stress doing this in phases.
Absolutely. Start small, prove the value, work out the kinks. Pilot programs are essential. Test with maybe 15–20% of your users, run it for 8–12 weeks.
Learn from that smaller group.
Exactly. Taking that gradual approach, phasing the deployment, it reduces major system incidents by up to 55% compared to a big bang rollout. Successful large-scale implementations. They typically take 6 to 8 months, sometimes longer, and they must include continuous monitoring and ways to feed user feedback right back into improving the system.
And that feedback loop pays off.
It seems to. That approach leads to about 45% higher user satisfaction rates in the end.
So if we tie this all together, connect it back to the big picture, the future path for finance seems pretty clearly defined by this push for optimization.
Yeah, the potential gains are just too large to ignore. We're looking at projections of cost reductions up to 40%, service quality improving by maybe 35%, and potentially reducing the need for humans to do routine manual tasks by as much as 80%. Gen AI is fundamentally shifting finance from just processing transactions to actually generating intelligence. But the price of that intelligence is constant vigilance, constant rigor.
Right. I think the main lesson, the key takeaway from all the source material today is that succeeding in this AI-driven future, it hinges completely on finding that balance. Balancing the aggressive innovation, embracing complex tools like JANs, VAEs, transformers, with really strict ethical and operational controls, things like XAI, robust fallback systems. You simply can't get the massive upside without accepting the equally massive ongoing responsibility.
Well said. And that brings us to our final thought, something for you, the listener, to reflect on. Given that constant monitoring and maintenance eats up nearly half the total cost over 5 years, how will financial institutions realistically balance that relentless pressure to innovate quickly with AI against the very real, very expensive, long-term commitment needed to keep these incredibly complex systems safe, compliant, and, crucially, free from bias?